Hi everyone, how are you today? We're going to be playing, well, not playing, we're going to be developing something in Godot 4. I'm not really sure what I'm doing yet, so you get to see the beginning of my process. I have a game concept, but that's it, so it's going to be interesting. Sorry, that's the ship's computer. It malfunctions sometimes. Well, the station's computer anyway. But anyway... I'm gonna be... I don't have a concept. Well, I do have a concept. I don't have anything else done yet, but it's gonna be really interesting, and I hope you enjoy staying with me and going on this journey together, trying to learn as we go. Because I am not the most experienced developer, but I enjoy it. So, I enjoy learning more. So hopefully this is gonna be a fun time, and we'll all learn something. In the meantime, what do you think of the improvements I've made to my clothing, hair, and, well, I won't tell you whether I added or removed a contact, but I definitely did one of those. So tell me what you think. But, I think we're ready to get started, and this will be fun. Alright, so... game concept. I'm going to try to make a roguelike. And that's basically the idea. That's basically the idea. I didn't even say anything yet. The point is, the idea is a roguelike based around collecting and using different kinds of dice. That's the idea. All sorts of different colors and shapes of dice. And... dice will have different rarities and different effects with different values depending on what faces you roll and things like that. So it's going to be a fairly complicated project, but I'm looking forward to it, and I think we can get started pretty easily here. So, where to begin? I do want this to be a mixed 2D, 3D project, where the main game is 2D, and then the dice are 3D. And I have actually, here's something I prepared earlier. I made some very basic dice. They're not currently textured because I ran out of time before the stream and I still was late. But the plan is to have the dice roll on top of the 2D environment so that you see the 3D dice roll on top of the 2D game. My goal will be to support both PC and mobile phones. And mostly Android, probably, because I don't feel like becoming an iOS developer. That seems very complicated and not my speed. So, in the meantime, let's take a look. So the first thing I want to do, just to prove that to myself that I can do it, is to make this sub-viewport under my 2D node, and then a 3D node under that with a camera. Because I think this is how you... And we're going to... I think this is how you layer 3D over 2D. So we're going to be trying it this way. Let's name this node 2D. We're going to call it Game Master. A word that is very familiar to me. So let's see. Okay, now that we've got that, let's save the scene. I hope I don't show anything by accident that I shouldn't. Otherwise, this stream may get blurred. I don't know why I deleted that. I think it was already correct. It's hard to split my focus this many ways, but it's fun at the same time. Set as main scene. Okay, let's go. All right. Now, under this node 3D, I want to just add the D20. And we'll move the camera. Back this way a little bit. And we'll see if that makes the... No. Now, it could just not be appearing because of the colors. Let's add sun to this node 3D. No, that's not correct. All right, let's see. Let's add a camera 2D. I think it needs to be up here, but I'm not entirely sure. Because we also need to be able to test that the camera 2D... Well, we don't really need a camera 2D, I don't think. But we need some kind of art asset. So if you don't mind, I'm going to quickly dive into my box of tricks. For a placeholder. Let's see. Okay. I should have prepared this in advance. Really should have prepared this in advance. Okay, let's see. Okay. Let me organize my project folder before it gets out of hand. Okay. Create new folder. We're going to call this one Panels 2D. Okay. Let's see. So let's put this panel beige down and test to make sure it's rendering. Okay, good. Now this sub viewport, how do we want this to work? I'm gonna need to look at the documentation for the sub viewport. Sub viewport container. Okay. Okay. All right, and now I understand. So I need a canvas. All right, now we've got something rendering. How fun. Never done that before. Okay. So we've got a sub viewport container. Let's see what we can do with this. Sub viewport. Okay. Now we're gonna have to tweak with this a bunch. Because what we want to do now... Oh, that's the directional light. That's fine. We want to take this camera... Rotate it -90 on the x-axis. Then move it up. Okay. Now, we take this D20 and move it up a little bit, and under this node 3D, which we're going to rename to Dice Environment. And we're going to call... No, we're not going to call anything. We're going to add a... What's it called? What is it called? Collision object, static body, collision shape 3D, and we're just going to go with a box shape. Down by 0.5 size at transform of -0.25. And then we're going to make this like 250 by 250 because we don't want anything to fall off the edge. Now, let's see. The next thing we want to do... Let's see about this. Let's open a new inherited scene from here. And we don't actually want this to be a static body 3D. We want this to be a, I believe a rigid body would make the most sense. Though, I suppose I could try it with a character body, but that sounds really complicated because I'd have to simulate the physics myself, and that sounds like a pain. Which means rather than generating the numbers through code and then adding the numbers or having the dice roll the numbers, the actual rolling of the rigid body is going to have to determine what the number is, I think. Which is not ideal. Certainly not for the early stages of the game. Development, that is. Okay. I have to remember how to do this. Okay, the dice models, let's see. Physics on. Dynamic. Shape type, automatic. Physics material override, re-import. Let's try that. Why do we have a static body under the... That's not right at all. You're going to say skip import, re-import, and see what happens then. This is a learning experience. Yeah, we're not going to be able to do it with the auto import. Not at my current skill level. So, we just need to extract the mesh from this. Save to file. Path. Dice models. E20 mesh. Okay. There's the mesh. All right, let's see. Okay, just 3 more to go. One left. Okay, we've got all the meshes, and now we just need to... Let's see here. Let's make a new scene. Other node. Rigid body 3D. Collision shape. There's probably something clever I could do with scenes here, but I don't grasp that well enough to, and like inheritance well enough to figure out what I should be doing. Convex polygon. No, we want concave polygon? Resource, no. How do we do it again? Concave polygon path. Okay, I understand now. Let's do the D6 first. That seems logical. What is this? What about the convex polygon? Is that going to throw the same error? Another resource is loaded from path. Possible cyclic resource inclusion. Don't quite know what to do now. Yeah, I think we're gonna go with the concave polygon. Wait, why is it not working now? Let's try the convex again. No? Now I'm confused. Because it was there, and now it's not. Oh. No, that doesn't make any sense. What am I doing? It's a cube. I'm loading a cube. I can just make a cube. And yes, I am still going to use the what? Why is that now a concave polygon? What have I done? That's weird. I guess that's probably why it wasn't working. Okay, so we've got a cube now, and let's save the scene as D6 object. Let's name this one table plane. This one table collider. Let's call this one actually not table plane. Let's call it table static body. And then under the dice environment, let's add this D6 object, give it a little bit of spin, and see what happens. Nice. I'm gonna add a second light to this scene under the first light. And the transform of this second one is going to be, let's see, where's the local? So we now have a second directional light that's in the opposite direction of the first one. And we're going to add light only, and then the light energy is going to be 0.5 on that, so we have half the energy that we do from the other direction. Okay. So that's that. Now we should probably have textures on this, but I don't really feel like doing that on stream right now. So let's instead look at how we can You know what? For fun, let's just make a bunch of dice and drop them down and see what happens. That's fun. I think the thing I'm going to work on today is getting the dice to throw when I click the button. So I'm going to have a button, and when you click the button, it throws the dice onto the screen. So we'll go back up to our canvas layer and add a button. All right, and on this button, we're going to say roll. And we're going to place this at the center bottom. Okay. And actually going to say bottom wide, like that. And then increase the, yeah. Okay. Now, what I want to know is if the die... Okay, the die is under the roll button. That's good. It's kind of how I want it. So the UI will be over the dice, and the game scene will be behind the dice. At least that's the plan. So let's stretch this out, and yeah, looks like that's how it's going to be. Okay, so we do want it like that for now, for testing. I got confused a little bit earlier, but I think we're good. So this sub viewport, no. Just want it like that. Now let's mess with the FOV of that camera a bit. Okay, that's looking good for now. All right. So we have a button, and it's labeled roll. So we're going to call it roll button. And it's just going to roll one die. It's going to instantiate one die when we click the button. Let's see here. We need boundaries on the screen, or the dice are going to roll off the side. So before we get going, let's preview that. Okay. Now let's add... Oh, let's preview it and make it orthographic. Ah! Okay. If that's the case, we're going to need to hide this die for now, and then when we have the orthographic projection, let's actually put the camera height a little different. Let's make it 8, because I like working in powers of 2 whenever possible. Actually, let's make it 12, because I also love the number 12. And then we can adjust everything, but that gives us plenty of room. Then, in the dice environment, we add a child node of a static body 3D. Under that, we add a collision shape, which will be a box shape. Now, when I do this... Ooh, that's going to be complicated. Am I going to have to math this? I don't want to have to math this. I don't like math. Yeah, that does seem to be correct. Now what happens if we turn off orthogonal? Oh no. That's not it at all. This is not how we need things to be. Okay, back to the drawing board. Okay, 16. That should work. No, it needs to be a little wider because it is actually... Okay, and then we change the box shape. Nope, we need that to be 1. This to be 20. And this to be 20. 50. Okay. Gonna make that unique. Although we don't really need to. Okay, if this one's at 18, this one must be at negative 18. Okay, and the size there, we're going to copy that value. Paste the value. All right. Then we're going to turn off these mesh instances. Bring this rigid body 3D back on. Go back into here. Name it D6. Okay. You know, I should have done this already, but I'm going to save this as a scene. Nice environment. Okay. So that we just go over here to edit this instead of having that one complicated. So we come to the dice environment. Preview. Add a new static body with a new mesh instance for now, because we need that to help position it. And a new collision shape. What am I doing? Brain melty. Okay, let's see here. Okay, let's not mess with that one. Okay, that looks like the right position to me. Okay, and then we duplicate this object. And we go to the transform. First for this one, we're going to round that out to 9.5. And this one, we're going to make negative 9.5. Hide those mesh instances, and let's hope that works. We'll come back and tweak it later if we need to. What? Right. Copy value. Paste value. There we go. Now, interesting. Okay, what I just discovered is that I can have two separate 3D objects parented to a sub viewport, and they will interact even if they're not parented the way I would normally parent scenes. So a sub viewport can act as a parent to multiple 3D objects, which is pretty cool. So, D6, huh? Right. Okay, I think we're ready to start the basic programming that I'm going to do today. But first, let's make this panel more or less fill the screen. Okay. I know there are better ways to do that, and I'll do them. Don't worry. This is the start. Okay, so this roll button, we want it probably under Game Master for now. We can always, what's the word, refactor? Refactoring is essential. You can't do everything right the first time. So we're going to grab the signal here, button, press, roll button. Okay, press Game Master Connect. And then over here, we're going to export var D6 object. Act scene. Okay. And then we're going to grab our D6 object, slot that in. And the next thing we're going to do is on roll button pressed, new die. What? Var die equals D6 object dot new instantiate. I think, oh gosh, my brain is fleeing me. D6 object dot instantiate. Trying to stream and program at the same time. Not easy, but fun. Okay, so we want to say, let's go to our D6 object. Let's make a new script in here, and we're going to call it die base. Extends rigid body 3D, not ideal, but fine. We're going to go class name die. Sounds very aggressive, doesn't it? Class name die. Okay. So we want export var. What are we going to call this? Mesh. Export var collider. And we've already got our, we already are rigid body 3D, so mesh instance 3D there. Collision shape 3D there. And we're going to save that scene for now. And then we're going to come in here. Collider and mesh. Now we can get reference to this directly, and it knows what kind of thing we're dealing with. Hopefully, if I remember how to do this correctly. All right, let's see. Die. I'm going to call this new die now, because die is now a type. So new die dot Can I do that? Is that gonna work? We're gonna apply force to the die. And remind me what that is again. It's a vector 3. Okay. We're just gonna go... Five, 10, 20. Why not? And then... It's going well so far. Thank you. Sorry, I should probably read that out. Hi, Alexis. How goes the learning? It's going well so far. Just a fun little time learning how to make a new roguelike. That's the idea, anyway. Not gonna get very far today in my streaming time that I have allotted, but it's been fun so far. Oh, we need to get a reference to our sub viewport. Export 3D view, we're gonna call it. Why is that number turning green? We're gonna call it dice view. Then. Okay, sub viewport. And now we need to get a reference to that sub viewport. Plug that in. New die, apply force. Okay, so now we need to and we need like a how do I want to do this? I could add a marker 3D for where I want the dice to appear, but I can't really randomize that too much, so I'm probably going to do it as a vector 2. I guess for simplicity, I can do a vector 3. No, I should do a vector 2. So let's add some space here so I can think. And let's see. Die location. Die spawn location. And then we add we make it a vector 2. And then on request we want to let's go to our dice environment scene, because what we've got in here is actually a decent basis for where our dice should appear. So if you got -18 and 9.5. So we want to go back and then die spawn location dot x equals rand f range Let's see, x should be the x value, obviously. So negative 18 to 18. Die spawn location dot y equals randf range negative 9.5 by 9.5. And now we have that when we press the button. So then we come down here and we say new die dot position equals vector 3, and then we want die spawn location dot x die, and then we want, like, it's at 12, so we want it to be 10 probably. And then die spawn location dot y in the z position, because we're dealing with sort of converting a vector 2 to a vector 3. Hey, look at that. Something's very wrong here with the viewport. But we are generating dice. They are not flinging in any way, but we'll get there. Let's try and apply impulse instead, because I think that's what we need. I saw a die fly by very quickly. Let's make this 555 and see what happens. Okay, but we don't want it to be in that axis, so we just want it to be this, and then we probably want to do randf range negative 5 to 5. Randf range negative 5 to 5. New die dot apply torque impulse. And then we're going to just copy this and see what happens. Oh, dice are appearing. Okay, let's try 50 by 50 for the torque. That should make it spin really crazy. Did it crash? No. Let's do 500 by 500 and see if we get some crazy spinning dice. No. Well, that's curious. So I guess we do need to do randf range for this one as well. Now let's see what happens. Too many arguments, expected 0, got 2. Oh, randf range, right. Hmm. Okay, one thing we can do to make this a little better is do new... No, let's do it after the position. New die... dot rotation... rotation degrees... equals... vector 3... randef range... negative 180 to 180. And then we're just going to copy that so we don't have to type it out a whole bunch. Now let's try it. Already that's better. The dice are actually rolling once they hit the ground, but they're not throwing yet. We also need to fix that viewport. Let's try to fix that viewport. So this sub viewport, I just want it to... I want it to match to the size of the... project settings. Let's just do it fast and dirty this way. Actually, let's... just set our window size to 1920 by 1080. 1920 by 1080. Let's go to our dice environment. Because now that we've got that way, I think I want the camera to be like that. And let's test that and make sure I moved it the right direction. I don't think I did. I'm very confused now. But no, that should be right, because that says it's up. Or does it? No, this... I think I'm upside down. Why is this upside down? What have I done wrong? Okay, it's not upside down anymore. It's just a bit weird. No, no, I think I do need it to be straight down. Negative 90. Okay, I think it does need to be straight down. Okay. So let's see here. Let's look at the documentation. Apply impulse. Vector 3 times 50. I don't know. Let's see if that fixes it. I think that's too much. I think that is too much. Let's try 5. All right, now we're getting somewhere. Let's change these torque impulses down to 50 and then multiply it by 100. We're going to try 100. And just see what happens. I think we're going to actually set this to 16 by 16 and 7.5 by 7.5, just so we don't accidentally make dice appear outside the bounds. Okay. You know what? Let's grab something I made the other day and see if this works. D6 object, D6 mesh, come in here, surface 0 material, albedo, texture, quick load, d6.png. Here we go. Now we've got numbers on our dice. It reads much more like dice rather than just cubes now. It's also complete chaos. But, you know, that's to be expected at the moment. Rather than having that panel be like that, I think we're going to go with a 9-patch rect. Panel beige, 9-patch rect. Now I have to remember how to do this. Grid snap. Okay. Hatch margins. Let's go with 50 by 50 by 50 by 50. Is that right? No. That's not how that works. Pixel snap. Ten. It's been a while since I worked with the 9-patch rect. You know what? It'll do for now. I think right now what we want to do is make the spawn location actually like 2 by 2, 1.5, 1.5. So they'll spawn mostly towards the center of the screen. We're gonna have to change the rotation or the velocity because I really want them to come in from the bottom of the screen, I think. By impulse. We're gonna try that. Okay, so they're all going basically the same direction now, but it's the wrong direction. -5 to 0. Die spawn location X and Y. Which is really X and Z. We're just going to change this to be 0. No. No, this one we actually want to be random. This one we want to be like -5 to 5. And this one we just want to be 0. Let's try that. I think we need a lot less impulse on that. Let's do 2.5. Ba-ba-da-ba. I think I have too many dice. But hey, why not, right? Okay, let's see. So we've got the basic dice throwing down. Do I need more? Let's see. I don't think we need this die spawn location anymore. I think that has served its purpose, more or less, and we can get rid of it. So let's try that again and make sure nothing broke. Okay. Do we want the... Oh, I realize what I've done wrong, why it wasn't working. Okay, we're good now. We're gonna go negative 9.5. Except that's too much. Negative 5? Let's try negative 5. Okay, let's try positive 5. I'll get my head around this camera angle eventually. There we go. Now we're starting to get somewhere. Okay. So now we need to do the hard part. For me, anyway. And that's figuring out how to get the face that is currently up from the die when it lands. When it stops. If anyone who is here happens to know a good way of doing that, please let me know in the chat. Because right now, I'm not quite sure. I guess I could get the rotation of the die once it lands. And figure out all the faces manually, but that sounds like a pain. And it seems like it would be hard to get if the die didn't land perfectly flat. If it was cocked in any way. So, let's see here. Let me think. Think. Well, we need to do it from this script. So... function... physics process. If... linear velocity equals 0. Let's try that first. Print landed. And I know print debugging is not great, but I'm doing it because I don't remember what the better way to do it is. Okay, if linear velocity dot sum is equal approximately. I've never used that function. Let's find out what it does. Vector 3 dot 0. Okay, it's getting that before as the dice are instantiated, which is not ideal. How do I want to do that? If linear velocity is equal approximately to vector 3.0, it landed. Let's look at this function. Okay. So, let's see. I don't want to have to make another area on this just to get the collision with the table. So what do I want to do? How do I want to do this? How do I want to do this? Let's check if we can get it exactly equal to 0. And it's still doing that as soon as they're instantiated. Let's see. Ooh, is 0 approx. That's a function that does the exact thing I need. More performantly, ideally. Linear velocity is 0 approx. Um... Yep, I'm just gonna have to add an area, I think. Okay, we got a little area on that, and then under the dice environment, we want the table static body to be collision layer 2. Mask 2, I think. I always get confused with those. Let's see. Let's see. Ooh. Okay, we'll try that. If sleeping equals true, print landed. Ooh. Sleeping equals true. Hey, var landed. Cool. If sleeping equals true and landed equals false, landed equals true. No, that's not how we should do this. Signal landed. If sleeping equals true and landed equals false, but at rest. We'll have an at rest variable, which will be a bool. And then at rest equals true, and that's like a gate. It'll keep it from happening more than once. And then we say landed dot emit. Then when we take this and we connect this to on landed, print landed. Let's try that. Do I need to make this an orthographic camera? I don't want to. Let's remove this area for now. Thank you. That's a nice looking dice. Thank you. I made it myself. It's got spider webs on it, but I don't know that you can see it from this size. Which is an interesting choice for me because I hate spiders. I'm scared to death of them. Let's see. Because they scare me. They scare me. Damn, how can you hate the cute little bugs? Because they scare me. They scare me greatly. And it is an irrational fear, I know it. I don't really hate them, I'm just terrified of them. There's a difference. Like, I know I shouldn't be scared of them. But I am. Let's do something fun. Let's add a... Let's add a CPU particle, because I think we have to use those on mobile. There's no law that states you can't be afraid of spiders. I know, it's just like, they don't deserve that. They're helpful sometimes. They get rid of other smaller pests and things, and they can stop mosquitoes and stuff, which are definitely the worst pests on Earth. But I'm just still scared of them. Let's see, where's our... Got our drawing. You know what? I'm not used to this. I'm going back to the 3D, the GPU particles. There we go. Particle billboard. Now in the process material, we go in here and... Alright, let's see. Turn off one shot for now for testing purposes. Okay, spawn, position, angle. Let's grab one of my placeholder textures I made. All right, let's see. Okay. Transparency alpha. Okay. Process material, we want the gravity. To be 0. And then we want the I don't understand orbit velocity. But we want the... Where's the size? Display. Scale over... Okay, scale. Scale curve, new curve texture. Okay, minimum 0. Huh? Why is this not working? Oh, right. I have to go down here. Keep scale off. Ah! That's big! Scale. There we go. And let's bump that up to like 16 particles. Good. Now, let's do an emission. Enabled. Pure white emission. Okay, now let's make this one shot. No longer emitting. Landed sparkle. I've seen... Okay, landed sparkle on landed. Sparkle emitting equals... There we go. That's fun. That's definitely fun. Okay. That is pretty good. At rest. Alright, there's probably better ways to do things right now, but eh. Okay, so I did have a little think while I was doing other stuff, and I think I may know the best way to get the side information for now. I'm gonna at least attempt this and see how it goes. So we're going to have a node 3D with a marker 3D underneath it. This node 3D is going to be called faces, and this marker 3D is going to be called face 1. Here we go. Copy, paste. Like 5.5. All right? Oh, 0. 0 and 0.5. That's phase 2. Let's find phase 3 and align it correctly. Phase 4 is opposite 3. Phase 5. What? I didn't duplicate that, apparently. So phase 5. Okay. Now that we have all of these faces, this is not the best way to do this. I know it's not, but I'm gonna have to research off stream, what the best way to actually do this is. So on landed, right? First, we need export var faces, node 3D, save, and then we come over here and we grab the faces. Okay. Now, for I in faces dot get child count, we want a new variable. And we're going to call it list of face list of faces. It's going to be an array of marker 3Ds. So we're going to delete that real quick. Now, list or I in I should have kept it. Get child count. I in faces such a get child count. Faces such a child count. Okay, so we get the I faces dot get child I list of faces dot add no list of faces dot append okay, now we've got those in there. There's a better way to do this. I'm sure there is. I in list of faces. We should do this on ready. So now we've got the list of faces. I in list of faces. List of faces I dot global position. Okay. Now that we've got that, in the list of faces, we're going to make a var for of face chords array vector 3. There's so much got to be a better way to do this. List of face chords. I'm trying to, hey, real quick, what are you trying to achieve at the moment? Random numbers or on the side, or knowing which number is on the top? I'm trying to know which number is on the top. Which number is on the top when the dice lands? When the die lands. Space chords dot append. Okay, is there a way you can use raycast or something to be like, if raycast is A is looking at ground, raycast is on the other side, is at the top? Theoretically, yeah, I could use raycasts. Right now, what I'm doing is getting the faces and finding out which of the faces has the highest Y value on, like, of its position. If that makes sense. If it, which face's position value has the highest Y. That way it should work better with dice that are not six-sided, in theory. But I think this is one of the things, and that I have spoken with a certain friend about, is that I do things in a very weird way that no one else would have thought of, and that's not necessarily always a good thing. So but we'll see. I just want to see if this works first before I try something else. Okay, let's get rid of the list of faces. I don't think we need. List of faces we do need. List of face coordinates we don't need. So let's do I dot global position dot Y if is greater than highest Y. We're gonna do this sloppy and quick. So we're gonna say face up string face up equals list of faces I got name. and then highest y equals list of faces I and then print face up. Oh, we got a crash. Invalid access to property or key face 1. Invalid access to property or key. Okay. We're going to export this variable now. The size, it needs to be 6 for this, and then we drag in each of these faces. That way, if I ever change the faces structure, it should keep the reference. So we don't need this anymore. We don't need this whole function. We don't need this. We don't, oh no. We'll keep it for now. But there's a built-in signal that does basically what I need. Print face up. Okay. Okay, is it the same error? What if we reference them as node 3Ds instead? Nope, that didn't work. All right, let's take a look real quick. Let's get that error back. Invalid access to property. Hmm. Well, I haven't fixed this yet, but I think I will fix it today, but not on stream, because I've hit my limit for streaming for right now. But this has been fun, and I think I'm going to do this again soon with the same project. I'm going to keep working on it off camera, but then I'm going to come back and continue it with all of you. So look forward to that, I guess. I hope you've all been well. I hope you all enjoyed the stream. But this is where I sign off. So until we meet again, stay safe, stay well, stay happy as best you can. And I will see you again soon. Goodbye.